Mr. Miller here to talk to you about the population of Andorra, which is a small country in Western Europe that you probably didn't know existed. But it is a small country. It only had 13,000 people in 1960, and in 1990 it had 54,000. So it grew quite a bit. And what we're going to do is make a model to help us predict what it will have in 2012, the number of people it will have in 2012. Now, we actually do know the answer to that, but we're going to see if we can build a model that will predict it. So, first, I would like to calculate the average absolute growth each year between 1960 and 1990. And you've already seen this on your warm-up, but here's how I did it. I just typed in equals average, selected all of the absolute growths from the past 30 years, and that's what I got, 1,370 people roughly. I can do the same thing for percentage growth. On average, in the average year, what percentage did the population grow by? And I could find it right there. If I want to adjust the rounding on that, I can just decrease the number of decimal places. And now we have sort of a report of the average year between 1960 and 1990 in Andorra. Now, I've hidden some cells here, and I've blocked out the true population up to 2012, and we don't actually even know after that. But one thing we do know for sure, we can clear those out. There were 54,511 people in 1990, and we're going to build two models, but they'll all start from that same place. Now, this first model will be based on absolute growth. We're going to repeatedly add 1370, which means it's an arithmetic sequence, and repeated adding we can also call a linear model. And here's how we'll do it. A simple formula. We'll take that number, the true population in 1990, and add 1370. And we can continue that on down if we want, all the way down to 2012. We can also do this with the exponential model. This will require repeated multiplication to grow by that percentage, which is why it's a geometric sequence. We should remember this from earlier in the year. And the formula, this is where it might get a little tricky, but instead of multiplying by what you might think, 0.048, which is, finding 4.8%, that only gets you the 2,000 that it's going to be growing by. So instead, we want to multiply by, we want 4.8% growth. We want 104.8% of the previous number. So we want to include the original and grow a little bit more. So we're going to need to multiply by a number greater than 1. Sure enough, we've got it here. When we multiply by 1.048, I can continue that on down. I can keep doing that. My question, though, is, and I'd like you to pause the video here, what will be the better model? This one as I continue it down to 2012, or this one, the arithmetic sequence, the linear model, or the exponential model? Pause the video and discuss. All right, I hope you thought about what would be the better model. We're going to continue these on down to 2012 and see which one turned out to produce a more accurate model. And that's the one that we'll continue on into 2050. And it's possible that maybe neither of these did. Let's uncover the true population and see what happened. All right, the population grew, and it looked like the linear model is keeping up very closely. And then something happened in Andorra. It looks like the population kind of topped out. And I think our model got a little messed up here. I'm going to have to see what happened. There we go. I think I fixed it. There was a problem with my formulas. But sure enough, the true population was 78,000, and the linear model predicted 84,000 compared to the exponential model, which was 152,000. So it looks like the linear one was much closer. That's the one I would continue all the way to 2050, although honestly I would probably revise it a little bit and maybe pick a smaller growth number. These are not the only two ways to make models. In fact, they're probably not the best ways or the most accurate, but they are ways. It's a good starting place. So I would start by doing this to get a prediction for 2050 for your country. Mine for Andorra, if I stick with this method, would be 136,711. But as I said, this will take some fine-tuning. I encourage you to watch my next screencast on how to make linear and exponential models in detail. It is available on Shasta 9, and that will tell you how to really fine-tune these and get them really great. Thanks for listening, and I will see you after expeditions.